Introduce presenter in this symposium. Dr. Matheus Freitas Fernandes-Pedrosa holds a degree in pharmacy from UFRN and a PhD in biotechnology from University of São Paulo. He was a senior researcher at Instituto Butantan and is currently a full professor in the Department of Pharmacy at Federal University of Rio Grande do Norte, as well as a CNPq Productivity Fellow 1B. He has extensive experience in biotechnology, focusing on scorpion peptides, antimicrobial peptides, snake proteins, and immunobiological production, holding 6 patents granted by INPI. He leads a team of 17 researchers and has supervised over 80 research projects among PhD, masters, and undergraduate. Dr. Fernandes-Pedrosa has international collaborations with institutions such as the University of Rouen, France, University of Granada and of Seville in Spain, and Nagasaki University in Japan. He was the executive manager of the BioInnova at UFRN Incubator and is a member of various ethics committees and councils, as well as leading projects funded by CNPq, CAPES, and FINEP. So, Professor Matheus, it's a pleasure to have you here.
Thank you very much, Professor. Do you have the pass? Okay. Good morning for everyone. Let me see. Okay for me. Okay, good morning, everyone. I'm Matheus Pedrosa from Federal University of Rio Grande do Norte, Brazil. I will show here a little bit that we have studied in the last 16 years. The Norte is from Brazil, and we have located at the Norte State. The Norte State is the state of Brazil, closer than and we have here studied about the teaching stigmurin scorpions that is predominant northeast Brazil. Teaching stigmurin is morphologically characterized by yellow scorpions from about 7 centimeters. These yellow scorpions presents usually a black strip on his back. Unfortunately, I cannot point to on its back you can see a black strip. Its head, a black triangle. The main peptides of the chemical composition are represented by neurotoxins, antimicrobials, We have performed the transcriptomic analysis about 14 years ago as a young study of our group, but it's a very important study because following the transcriptomic results, we have identified the high abundance transcripts present in the Venom gland of Tithys stigmuds. We can observe that about 70% of the molecules represented other possible venom molecules and toxins, no toxins molecules. And we can highlight an anionic peptide, AMP, alpha and beta KTX, metalloprotease and hypotensin as the main molecules expressed in this specialized gland venom of Titus stigmosus scorpion. So after this step of transcriptomic analysis, we have identified and isolated the peptide that we have named stigmurin. Stigmurin is a peptide present in 17 amino acids in his primary structure, about 1.8 kilodaltons. At the first moment, stigmurin was positive against gram-positive bacteria and yeasts of genus Candida, and stigmurin was not effective against gram-negative bacteria. In the biocompatibility assays, we have observed that stigmurin was no toxic for hemolysis experiment, and for normal cells, viral E6, stigmurin was no toxic until 17 micromolar, and tests against cells SIHA for adenocarcinoma of women, stigmurin was toxic until 70 or more, 70 micromolar. So in the next step, we have used the primary sequence of stigmurin as reference and based on literature to bioinformatic analysis that we have observed in specific points on its structure, on its primary structure. We have inserted lysine and focus on to obtain new analog peptides with increasement of their alpha helix and the positive charge to better interaction with the membrane of bacteria and to reduce the cytotoxicity. So we have obtained 31 analog peptides. We have deposited this patent in 2015. And now, last year, we received the patent letter in 2023 from ENPI from Brazil. Here we have this. Ok. Aperta e segura. Ok. Obrigado. Thank you. No, with me. Okay. Here we have presented the primary structure of stigmurin, amidate sequence. We have the 8 analogs that we have studied in more details. We can see some new peptides. We have inserted lysine and in 2 positions, replaced by serine or glycine, for example. In 3 positions, 7 and 14. In 4 positions, for example, in positions 1, 2, 3, and 4. And the most aggressive mutation we have obtained Stig 31, 5 replacements for lysine. We can observe for bioinformatics the increase of alpha helix, the increasement of positive charge. So we have on the next step, we have analyzed the native peptides at the first time in comparison with the analog Stig A15 here by experimental NMR 800 megahertz in Rio de Janeiro in collaboration with Professor Fábio Almeida at Federal University of Rio de Janeiro. The final result of the structure, Professor Jarbas was very important in the structural resolution of these both molecular structures, and we can observe the stigmurin, the start of the alpha helix in position serine 7, until phenylalanine 16, while if in the comparison we can observe the start of alpha helix in analog peptides 2 amino acids before isoleucine 5 until phenylalanine 16. Here we have confirmed the alpha helix predomination and that alpha helix was increasement in the analog peptides that we have generated in our group. following with the pharmacological test with stigmurin, the native peptide, we have performed we have performed experiments focused on one healing activity of this native peptide. So we have performed these experiments in mice. We have promoted the wound in the skin of the animals. In first column, the uninfected control. In the second column, we have promoted the wound and infected with Staphylococcus aureus. In the third column, we treated the infected wound with Staphylococcus aureus with stigmurin 1 microgram per microliters. And we have followed the the activity for 7 days with one analysis per day. So we have performed the counting of the colonies. We can observe the decreasement of the counting of the colonies. Here we have the stigmurin, and in comparison, always with vancomycin, the market antibiotic for this proposal. So in the next step, we have performed some more details in experiments focused on 2 analog peptides, named STIG8 and STIG18. Here we have the new sequence based on stigmurin. Stigmurin, the first sequence, the 18, two mutations, serine 7 and glycine for lysine 10. And 18, we have 3 mutations in positions 7, 10, and 14. We have analyzed the increasement of hydrophobic moment, the decreasement of hydrophobicity, the increasement of cation charge, and here we have presented the molecular mass of each peptide. We have analyzed the stability of these peptides by circular decrease in the first moment, and we have analyzed both peptides in different media, water, PBS, SDS, and a range of TFA, beginning at 20% until 7%. And we can observe in these results that both peptides show the predominance of alpha helix above 50%, and stability in different media, in special TFA and SDS. Experiments focus on variation of pH in a range of 3 to 9. Both peptides showed a high stability, in special STIG18, with maintenance of their conformation, structural conformation, about more than 50% of helix. And the third and last experiment, we have rating the peptides until 98 degrees. After this, we have cooling both peptides, and we could observe the discrete light difference of conformation when we reach until 98, but the conformation returns to original structure in the end of the reaction after cooling. So these experiments taken together, we can observe an important stability of these peptides in different media, pH, and temperature. So in the next step, with both analog peptides, involving both peptides, we have analyzed by dynamic circular, molecular dynamic experiments by bioinformatic analysis, the membrane peptide interaction. And we can observe for the first column, STIG8, second column, STIG18, here. At the first moment, in the experiments involving both peptides and membrane of Staphylococcus aureus, we can analyze that the peptide binding with the membrane by electrostatic interaction at the first moment, and we could observe also that the first contact occurs in in basic and polar regions of the peptides, basic and polar regions. And the third moment, the peptides inside deep the membrane involved with the phospholipid group to promote the lysis of the membrane of the bacteria. Following for the next experiments involving biocompatibility tests of both analog peptides, we have analyzed by the cytotoxic in tests with hemolysis and larvae of the species Galera melonella. In both experiments, in all concentrations that we have tested, the peptides showed that was no toxic against this model of cytotoxic experiments. And for in table 3, we have performed and showed here the determination of MIC and MBC of stigmurin in both peptides against gram-positive and gram-negative bacteria. So we can observe from against the gram-positive bacteria, stigmurin was effective. According to the preliminary experiments that we have shown in the beginning of the presentation, in comparison with the analog peptides were more effective in lower concentration, was effective from gram-positive bacteria. And from negative bacteria, gram-negative bacteria, stigmurin was confirmed that was not effective, while both analog peptides were effective against E. coli and Pseudomonas aeruginosa. In experiments conducted by focus on treatment of early biofilm and late biofilm involving both peptides on biofilm of multi-drug resistant Staphylococcus aureus clinical isolates. We have performed in these experiments involving 7 streams of Staphylococcus aureus, and we have tested in 3 concentrations of both analog peptides and 3 concentrations of vancomycin, our positive control. We can observe for the majority of the streams that we have tested, we can observe important values of inhibition of early biofilm. The first side is early biofilm, and on the right, we can observe the late biofilm. So we can observe values important as 78%, about 60%, 57%. So we can summary in the result between 50 and 78%. It's an important value if we compare similar values found with vancomycin. For late biofilm, we have important inhibition too, but the values was not so higher than early biofilm. We can observe the variation between 35 to 60% the better results, and these results follow the results presented by vancomycin. So we have the topography of electronic scanner, electronic microscopy. We have observed colonies without treatment, and colonies treated with Stig, in this case for early biofilm, treated with Stig A and Stig 18. We can observe the decreasement of the colonies, the fragmentation of the colonies, the pore formations between the membrane of the colonies. So this picture is about the late biofilm for the Staphylococcus aureus, the same streams, and we can observe the more aggressive result in stage 18. Regarding stage 18, we have 3 mutations. The result is more aggressive if compared with stage 8 with 2 mutations, 3 insertions of lysine. So to conclude the pharmacological tests focus on both analog peptides, we have infected larvae of species Galera melonella with multi-drug resistant Staphylococcus aureus, clinical isolate. And we have analyzed the survival of the animals for 7 days in comparison with infected control, vancomycin in higher concentration, STIG8 with 2 mutations and 2 concentration, STIG18 in 3 concentration. We can observe that vancomycin was able to maintain the survival of the animals for 7 days, and STIG8 and STIG18 for 5 to 6 days, and a better result for the STIG18 in the higher concentration. So we have 3 possibilities of 3 hypotheses of mechanism of action of our peptides. We have the possibility of toroidal pore, we have the possibility of the carpet and barrier stave. Our hypothesis, we don't have results enough to conclude to close a hypothesis, but our hypothesis, based on our preliminary studies, is the mechanism of action is focused on carpet, when the peptides in agglomeration in peptides forms an overlay of the peptides that can disrupt the membrane, acting as similar as an emulsifier agent to promote the disruption of membrane after the overlay of the agglomeration of the peptides. The dynamic simulation I did not show, but the dynamic simulation was performed with 1 peptide and with the agglomeration of peptides. And this point is important to reinforce the possibility of the hypothesis of carpet model. Other important point that we have continued this study, maybe on NMR in solid phase, is focused on the target, molecular target that our antimicrobial peptides can interact in the positive or gram-negative bacteria. We can highlight teichoic acid as a possibility and lipoteichoic acid as a possibility too for gram-positive negative bacteria in the membrane interaction of the peptides, and LPS for gram-negative bacteria. These possibilities that we have focused. We have continued these experiments to obtain results in more detail with the interaction with collaborators in Europe. So now we have, in parallel, we have performed the second patent focused on new analog peptides based on native peptides as a reference. And we have invested efforts to study in more detail the native peptide TSP2. TSP2 is a second majority peptide present in Titus stigmurin scorpion, belongs to the class of AMP. The stigmurin was the majorities, TSP2 the second majority. And for this case, we have analyzed the primary structure of TSP2, and we have inserted lysine or arginine, or both lysine and arginine. We have obtained 41 analog peptides. We have performed a study of top-down. We have generated more than 100 peptides, and for bioinformatic analysis in more details, we was closing the sequence, and for top-down analysis, we have closed it in 41 peptides. Other peptides that we have preliminary studies in our group is the majority class of peptides we have observed in transcriptomic analysis, the anionic peptides that we have named in our first article with these peptides, TAMP, anionic peptides of Titus stigmuris. This peptide is chelating for ions copper in a proportion 1 peptide for 5 molecules of ion copper. It's a big sequence, about 44 amino acids. And we can observe the predominance of aspartic acid. We have identified this peptide in mass spectrometry, and we have evaluated the chelating properties, the chelating properties with other ions like iron, like magnesium, calcium. But the most promising ion was the result focused on ions copper. We have analyzed the immunomodulatory activity in macrophage cells and have performed other experiments focused on this peptide. And we intend to obtain a product in the future to chelating ions and deposit a new patent. Another peptide that we have preliminary studies in our group is a high-potency peptide. High-potency peptide presents a primary structure about 25 amino acids with the domain characterized for high-potency, the domain PPA. We have performed in collaboration with Professor Valdir Braga. The experiments focus on vasorelaxante activity. We have studied also the Bragg-Senin potentiation activity. We have tested the efficacy of these peptides in some antimicrobial models. We have analyzed the toxicity of these peptides. So we have to continue this study to study in more details, but we have promoted some alteration, some chemical alteration in this on X structure. We have deposited a patent focused on a new candidate for antihypertensive drug in pharmaceutical area. So our perspectives, we have 7 native peptides, we have 2 analog peptides. We have continuous in collaboration with Professor Sylvie from University of Rouen in France. We have focused on mechanism of action, focus in the first moment with Pseudomonas aeruginosa. We have already studied this focus in France, but we have continued for the group SCAPE, Enterococcus, Staphylococcus, Klebsiella, Cinobacter, and Enterobacter group. The group SCAPE is the group very important for OMS because the high resistance of these microorganisms. We have to continue the NMR analysis from the other native and analog peptides. We have to continue topical formulations, focus on the studies to apply this product as wound healing treatment. We have now performing results that not published yet for focus on synergism. We have observed in for some antibiotics, synergism or additive effects. The anti-insect activity we have also started nowadays. And we hope that in the future, nowadays, if what's possible, but in the near future, a partnership with our pharmaceutical industry. We have a patent letter, but we don't have now a pharmaceutical industry to make business, to invest in our molecules. So we wait for opportunities to deal with pharmaceutical industry. To conclude, some important collaborators of our experiments, Professor Fábio Almeida from Federal of Rio de Janeiro. We always, every year, we have to stay there for two or 3 weeks, sometimes 4 weeks. We have usually traveled 2 or 3 times in a year for Rio de Janeiro. And this is very important because we have the equipment with 800 megahertz to analyze our molecules. We have also collaboration with Professor Jarbas Rezende that is here in our Congress. Jarbas is very important to synthesize our peptides and resolution of the structural conformation of our peptides that we have acquired the date from NMR 8 megahertz. Professor Renata Mendonça is so important, our collaborator from Chemical Institute of Rio Grande do Norte. This picture was in Department of Chemical from Federal University of Minas Gerais, here in Rio de Janeiro. And we have also to thank Professor Rafael Ximenes from Federal do Rio de Janeiro for the Staphylococcus aureus multi-resistant clinical isolate, and Professor Sylvie Chevalier from Université de Rouen in France. We have started the experiments focused on mechanism of action of our peptides, not only 2 analog peptides, but a pool of analog peptides against Pseudomonas aeruginosa. And nowadays, we have 2 postdocs in performing experiments in Universidade de Granada in Spain and Universidade de Seville in the same country. They are performing the production formulation tablets for antihypotensin, hypotensin toxins, and dressing for that wound treatment with our peptides is a project that we got the success in PQ last year. The postdocs will stay 6 months in Seville and Granada. After this, they will to France for more 6 months. Okay, I'd like to thank all the collaborators. We have collaborators here at Universidade from Brasília, Professor Elizabeth Ferrone, Professor Werner Triptel. We have now got the 2nd project approved in coordination by Professor Werner Triptel. Part of our group, postdocs, doctoral students, master, and scientific initiative students, and UFRN Natal. Thanks for your attention.
Thank you for your presentation. And now it's open for questions.
Congratulations with all the results and the beautiful presentation. I was interested in particular in the anionic peptide, since it can chelate copper. Do you see any application in clinical toxicology in terms of metal intoxications to treat patients, or do you expect that the side effects would be bigger because it may also chelate calcium, and then of course it is very dangerous for the heart? What's your opinion? Is this molecule a potential drug for an antidote?
Yes, this is a very good point. We have tested, and we have only performed preliminary tests in culture cells, and we have only proved that this peptide was not toxic for fibroblasts and other kidney cells, only for this, but for iron calcium, the peptide was not efficient. The better efficient, the stronger binding interaction occurs with iron copper only. Iron, calcium, magnesium, it's not so good, the chelating. So we plan to use these peptides maybe on agricultural area for promoting new molecules for anti-insect activity, maybe a possibility. And the other possibility is for cancer cells in the cerebral, brain cancer cells, or some diseases in brain. But we have to study deeper to apply these peptides. We have only preliminary studies. Maybe we have in our hands important molecule. We have to study in more details to apply on toxicology for pharmacological approach. Okay, thank you very much.
Does it have causative? Yes, isolate with se já vem com íon quando você purifica, ela vem sem.
This is a good point. It's not constitutive. To see, we could observe the interaction in mass spectrometry, but we have to put in contact in experimental analysis peptide with ion and observe in mass spectrometry. but it's not constitutive. It's very good. It's a very good point. Thank you.
Very nice talk. It's very nice to see you again after so many years. So I was interested in stigmurin. So I saw that you just understand a helix by using NMR. And my question is, what kind of conditions did you use to see these NMR structures? Because what I'm seeing is that I'm seeing a coil that was transforming in a helix when I have the peptide binding in the membrane. And I saw that you basically see a helix. So what kind of conditions did you use to elucidate the structure?
Thank you, Professor Otávio. It's a very good point. We have used the condition of TFE about 40–50%. We have now obtained the new condition involving SDS, 20 millimolar. We have other conditions that we have planning to study for a new paper. But this point was very discussed in our published article because almost all of the supervisors focus on this point, but we have at the first moment in the first paper we have performed these experiments involving a range of TFA. Because of this, in the first experiment focused on NMR, we have selected TFA in two concentrations, 40 to 50. But we know that in the second moment we have to present in other condition in special SDS. A lot of supervisors of the paper required SDS. But it's not easy because it's not easy to use the equipment, to use the resolution. We have support of Professor Jarbas, Professor Fábio, and nowadays we have to conclude the experiment focus on SDS to present for literature. It's a very, very important point. Okay, thank you very much. Okay. Thank you, Professor. Okay, now I will present the next researcher, Professor Octávio Luiz Franco. Octávio Luiz Franco has a degree in biological science from Federal University of Ceará and PhD in biological science from the University of Brasília.